So just I want to review a little bit about correlation coefficient. What is correlation coefficient? To be exact, the Pearson's sample correlation coefficient. Usually we use symbol R for this, the Pearson's sample correlation, and that is calculated on, in general, n observation, n pair of observations, x1, y1 to xn, yn, and R is defined by s sub xy over s sub x, s sub y. And s sub x and s sub y are standard deviations. And how about the s sub xy? S sub xy is so-called covariance between x and y. So the definition is this. So this is similar to variance, but the one factor here within the summation is replaced by the yi minus y bar. So it actually expresses the relationship between x and y. Here, x bar and y bar are mean of x i's and mean of y i's. The correlation coefficient have this property. So sample correlation coefficient always between -1 and 1. If correlation coefficient is positive, we have positive linear relationship. So that means if x is larger, y tends to be larger. It's not perfectly a clear relationship, but if x is higher, we expect the y is somewhat high. If R is negative, the other way around, x increases, then y decreases. R is equal to 0, then x and y does not have a linear relationship. So it does not mean no relationship, but at least the larger x does not imply larger y or smaller y. So these examples that show the idea. So at first, maybe we can see the upper 7 graphs. So if correlation coefficient is 0, okay, so x, and so the larger x does not mean larger y or smaller y. If correlation coefficient is 0.4, we have some weak tendency that when x is larger, y is also somewhat large. If correlation coefficient is 0.8, so the relationship is stronger. And if correlation coefficient is 1, it's perfect relationship. That is all points. Okay, so this is, okay, so x-axis and y-axis here, even though these are not on the page. So the points x, y, x, I, y, I are on the same line with a positive slope. That is correlation coefficient of 1. And the negative case, we have the same, negative 0.4, negative 0.8, and a negative 1. And the slope isn't really related to correlation coefficient. Correlation coefficient is a kind of scale-free measure of relationship between x and y. For example, if x is weight and y is height, if x is measured in kilogram or pound, the correlation coefficient doesn't change. Also, if y changes from centimeter to inch or a meter, the correlation coefficient still stays the same. So the slope, if the slope is different, still the correlation coefficient does not change. So if all points are on the same line with a positive slope, always correlation coefficient is 1, even though slope is smaller. And if observations are entirely flat, I mean the y values don't have any variability, then we cannot calculate correlation coefficient. That is because we have the s sub y, standard deviation of y, on the denominator in the definition of correlation coefficient. So that means the denominator becomes 0 if y does not have variation. So we cannot define. And also, if all points are on a vertical line, we cannot calculate, we cannot define correlation coefficient. Because if the y does not have variation, then we cannot say larger x tends to mean larger y. So we cannot define the relationship between x and y. Okay, and the correlation coefficient is 0. If correlation coefficient is 0, it does not mean there is no relationship. For example, this pattern has correlation coefficient, sample correlation coefficient of 0. Because the larger x, that does not imply larger y. Okay, so if x is around 0, then y value is larger than other cases. But okay, so maybe the if x is negative around here, maybe 0 to negative of this value, we have some positive relationship, but here negative relationship, and here positive relationship. So the overall, we don't have any tendency about linear relationship between x and y. Larger x does not mean larger y, and does not mean smaller y either. And also the next graph, we have obviously pattern here. So all points are within a square, the tilted square. But still, you cannot see. We cannot make a we cannot describe any tendency. Okay, so if the correlation coefficient is 0.8 or 0.4, then we can see the trend line. We can draw a trend line. But here, if we want to make a trend line, that is almost arbitrary. So we don't have any linear relationship. Okay, so here the same, and here is also the same. Also this one, that we have obviously some pattern. All points are on one of the two parabolas, but actually we don't have any linear relationship. Also this, we have all points are on a circle, maybe plus some noise. And we have 4 clusters, but still we don't have linear relationship. So correlation coefficient of 0 does not mean no relationship, but at least we don't have no linear relationship if R is 0. And why this kind of graph is true? I mean, why just one number can represent the positive or negative relationship between x and y? The answer is here. So remember that the correlation coefficient, in the definition of correlation coefficient, we have summation of parenthesis xi minus x bar times parenthesis yi minus y bar. So if these two factors are both positive, then product is positive. One of these are positive, one of these are negative, then product is negative. Both are negative, then product is positive. That is the key fact to explain why correlation coefficient is positive when we have positive linear relationship. So you can see the first pane of these graphs. So you can see that if the x and y have positive relationship, when xi minus x bar is positive, that is x value is larger than the center of the x values, then y value tends to be larger than y bar, because most points are in the quadrant 1 or quadrant 3. And also, if x value is less than x bar, then the first factor here is negative, but the y value tends to be negative, tends to be less than y bar. So most points are in the quadrant 1 and 3. So that means the most summand is positive. Okay, so maybe some exceptions, but the overall, we expect that summation is positive, so it has positive relationship. So the same thing applies for, excuse me, negative relationship. So if we have negative linear relationship between x and y, the most points are quadrant 2 or 4. And in this case, the product of xi minus x bar times yi minus y bar is negative. Okay. So here, quadrant 2, the first factor, xi minus x bar is negative, but yi minus y bar is positive, so product is negative. And quadrant 4, the other way around. If no pattern, of course, the observations are put randomly in all 4 quadrants. So that means correlation coefficient is near 0. Yep. So correlation coefficient is calculated by just this C or R function, but for practice purpose, I want to explain that this can be done also by more basic functions. For example, okay, so just for simplicity, we define x as midterm 1, y as midterm 2. Or the semicolon ends the line. Okay, so actually, even if we don't put this, the result is the same. But if you want to put the two command in one line, you have to put the semicolon in between the two different command. Okay, so yeah, x and y. So the standard deviation is x minus x bar. So x bar is mean over x. So this one. And take square, then take summation. Maybe this is too redundant. So maybe we just try to define the covariance from scratch. But the standard deviation that we use the formula, the ready-made function. So okay, so this part is actually the inside the summation, the summand part, the xi minus x bar times yi minus y bar. Okay, then take summation. Then we divide this by n minus 1. We have 5 observations, so 5 minus 1. So this is covariance S sub xy. We name it as SXY. Then SXY is 700. SXY divided by standard deviation of x times standard deviation of y. We get 0.7. So we can use either function, correlation function, or we can make everything from scratch.